So, hey everyone, this today's class is about the concepts of acids and bases, and we are going to start up with the very classical concept, right? We have three main concepts which are prevailing at this moment, but the things which started, when you start chemistry. So, what kind of things you have in your mind? First is when I talk about the classic concept, the acids, they are the substances. The key things which come in my mind is that acids are sour in taste, right? They are sour in taste. Like, for example, lemon, tomato, they are sour in taste, right? When I'll make an aqueous solution of acid, they are going to conduct electricity. Like, this was a very keen concept which was there, which was prevalent from the ancient times, right? So aqueous solutions of these are going to conduct electricity, right? So this indicates that they'll be having, mobile ions, or we can say mobile electrons, because, for conduction of electricity, we require some movement of the electrons, right? So this means that acids will be having that, but the condition is the solution has to be aqueous, right? Then the next thing which comes in my mind is acids, they turn blue litmus red, if I am not wrong, right? Yes, John?
Yeah,
Yeah. You know what? When we were young, so this is very confusing for a young student, right? Blue to red or red to blue. So you get on very confused about that. So what thing our teachers told us that this red means it's a danger, right? It's a sign of danger. And acids, they are also danger, right? Because we are always told us, like every teacher or every instructor, lab instructor will tell you that stay away from the acids, right? They are going to burn your skin. So danger means red color, and obviously acids are going to show the change in color in the litmus paper as blue to red, right? Then I talk about that if acids they come in contact with any base now, its acidic properties are going to just fly away, right? They'll be neutralized. The properties will be gone. So whenever this acid is going to come in contact with base, right? Come in contact with a base, so its properties are acidic properties are gone, right? Because they cancel out each other. We are going to talk about that also. So the properties are going to be, gone, right? Now, if I talk about the base, what are bases? Like this concept now is basically in the you can say earlier sections, earlier years of education, because we need to have a very, a picture of the things which, got so much into the evolution, how that came up, like the recent concepts from like how was the progress. So for that, we need to learn about the classic concept also. So bases are basically, they are bitter in taste. B for bases, and B is for bitter, right? Bitter in taste. Like for example, soap. If by chance a soap goes into your mouth, you are going to feel like a little bit bitterness, right? They are soapy to touch. They are very soapy to touch. Again, if they are found in the aqueous solution, they are going to conduct electricity. Okay, they are also good conductors of electricity, which means that again they are having free electrons, or I can say free ions, which is going to support the flow of electricity, right? Again, I talked about the contact of acid and base. So obviously, this point is also going to be with the base also. The base will be losing its, basic properties. So in the end, what we have talked about, that this is the concept is there in our mind when we are going for the higher education, right? Up now, this concept is too generalized, right? It is too generalized. We cannot make out the things, we cannot justify all the things in this, right? The kind of properties which acids and bases show us, it is not explained by this very general concept. Now, the next concept which came on the scene was Arrhenius concept, right? He gave us a very, very sound concept of acids and bases. So, Arrhenius concept was basically, see, he gave us a theory of ionization. Okay, first of all, just listen to what he did before he gave us the concept, right? In science, you when you're reaching something, in between, yeah, in the way, on the way, you are going to fetch so many things. So when he was just studying about acid and bases, before that, he came up with this thing that an electrolyte which is dissolved in water. Okay, first of all, I'm just telling the concept. After that, we are going to bifurcate the words. Okay, we are going to understand each and every word. When an electrolyte is dissolved in water, okay, it dissociates into positive or negative ions. Okay, now I'm going to write this thing. Arrhenius gave us the theory of ionization. Okay, what does this theory say? Electrolytes, when dissolved in water, okay, when they're dissolved in water, obviously they are going to form aqueous solution. So now they are in the solution form and they'll show dissociation. Dissociation means breaking up, right? Dissociation into positively or negatively charged ions, depending on the kind of electrolyte. Now, in this theory, what are the keywords? The first keyword is electrolyte. What is electrolyte? Electrolyte is basically a liquid which conducts electricity. Okay, because when we are talking about electricity, na, I don't know about you, but it's like if I talk about myself, na, so I have in my mind wires, geysers. So all solid things come in my mind. No liquid comes in my mind, right? But yes, liquids do conduct electricity, and those liquids are called as electrolytes. Okay. So dissolved in water means ki it is in the solution form, right? Next word, the key word is your dissociation. What do you mean by dissociation? Dissociation is basically breaking down. Okay. It means breaking down. You are breaking the compound. Okay. Obviously, the electrolyte, as it is a good conductor of electricity, naturally it will be having positive and negative ions. Positively charged ions are called as the cations, right? And the negatively charged ions are called anions. Got it? Now, according to this concept, now he just, applied this theory of ionization on the acids and bases and how it came up. See, now, when he talked about acids, now he said that acids are the substances having hydrogen. First of all, he gave us this thing that acids are substances which contain hydrogen. Matlab, he said that any substance having hydrogen in it is going to be acidic in nature. Okay? Which has hydrogen. Okay? And when this substance is dissolved in water, okay, it is dissolved in water, na? So it is going to form ions. And which ions are going to be formed? Hydrogen ions. Is this clear? Yes. So according to Arrhenius, acids are the substances containing hydrogen, and when dissolved in water, they are going to form hydrogen ions. Is that clear? Right? Now,
Yeah.
depending upon how an acid dissociates, means to what extent an acid is dissociating. What does this mean? I mean to say that whether the dissociation is complete or incomplete, that is going to give me two types of acids. One is strong, okay, and the other one is weak. Now, what do you mean by strong and weak? They are not bodybuilders, right? Of course, they are not bodybuilders, but yes, they are going to show complete dissociation, right? For example, if I talk about HCl, so HCl, when it is dissolved in water, it is aqueous solution, then it is going to form hydrogen ion and chloride ions. And there will be no unionized molecule present in solution. Only ions will be there. Okay, so strong acid, the characteristic property of strong acid is complete dissociation. Is this clear?
Yeah.
Yeah, there is complete dissociation. So when I talk about the weak acids, so that means there will be incomplete dissociation, right? Dissociation will be there, but it will not be complete, right? So, Sean, tell me one thing. If there is incomplete dissociation, so what will you find in the solution? Like what you're going to see in the solution? What things are you going to find in the solution? The question is this. Okay. Hmm.
Right.
Okay, you didn't get the question?
Mm,
Acha, okay. I'll give you hint, but you have to answer. Okay. I talked about the strong acid, na? So I told you that it is going to show me complete dissociation, right? And it resulted in the formation of ions. Clear? Right? And I told you कि as it is complete dissociation, so that means there will be no molecule present in the solution. All will be converted into ions. Got it?
Yeah.
Yeah. Now I'm saying that weak acids are showing incomplete dissociation. So what does that mean?
That there will be molecules.
Yeah, there will be ions. Yes, very good. Next.
Um, they won't all turn into ions or something.
They will all turn into ions, or some
No,
molecules
they
will
won't.
turn ions.
Yeah, some. No.
Some. So there must be some molecules which are left unionized. Got it? So that means
Yeah.
if I see the solution of a weak acid, so what I'm going to see, I'm going to find ions, and I'm going to find unionized molecules also. Got it? This is the thing. This is the difference between strong and weak acid. Okay, now can you think of an example of a weak acid?
No.
Okay, I'll give you a hint. See, a strong acid cannot be, taken by us. Like, for example, if I'm going to have that H2SO4, I cannot drink that. I cannot,
Yeah.
right? But weak acids I can consume, and I do consume. Although I don't consume, but I know you must be consuming that in the form of cold drinks. It's carbonic acid. Okay, otherwise, what would have happened? It would have been, hurting your esophagus, all the digestive things. So, how come we can have that acid? No. So, the weak acid is carbonic acid, as well as all the organic acids, they are weak in nature. Okay, like for example, we do take lemon water, we do consume that, we do take tomatoes, right? They are all acidic in nature, right? We do take spinach. It is also having acid in it, but we are taking it. We are enjoying the things, right? But it is not hurting us. But if you just think of when you take cold drink, sometimes it, enters our nose and we have a burning sensation, right? Sometimes, right? So why this burning sensation? Because obviously it has acidic properties. So I hope this is clear to you, right? Okay, now we are going to define basis on the Arrhenius theory. Okay. Okay. Now comes our basis. So how Arrhenius defined them? He said the substances which have OH group. Okay. The substances having hydroxide group, and they are going to form hydroxyl ion when dissolved in water. Okay. So which type of ion is formed? OH ions when dissolved in water. Okay, ji. This is your hydroxyl ion. Okay, OH ion, OH negative. And this H ion, it is very unstable. It doesn't show independent existence. So what it does, it readily combines with a molecule of water to form hydronium ion. This is hydronium ion, H3O positive. Got it? The name of this ion is hydronium ion. Okay, and the ion which is, uh, made by the bases when they show dissociation, that is hydroxyl ion, OH negative. Is that clear? Again, the bases, depending upon the extent of dissociation, they are further divided into two categories. One is strong, right? And the other one is weak, right? Now, strong, the same concept, it is going to show complete or incomplete
Association.
dissociation. Complete or incomplete?
Complete.
Complete, yes. So it is going to show us complete dissociation into ions. And can you think of any example of a weak base? Okay, do you know any base, first of all? Any chemical?
Any chemical.
Any chemical which is basic in nature. Do you have any idea about that?
Um, no.
No, okay. If I say NaOH, so is there something which is coming in your mind? If I'm saying
Yeah.
NaOH, yeah, then tell me what's coming in your mind.
Like what NaOH is?
NaOH, yes. And any other similar compound?
Oh, would like HCl be one? Would that be one?
Can you repeat?
HCl, would that like the one?
Oh, HCl, though it has hydrogen, na, so it is going to fit in the acid category. It is not going to
Oh,
fit in base category. It ought to have OH as per the Arrhenius, right? So potassium is also a metal, right? So potassium hydroxide, again a strong base. Okay, got
yeah.
it? Oh, when we are talking about the weak bases, now you are going to tell me whether they are going to show complete dissociation or incomplete dissociation.
Okay.
The weak one, incomplete, yeah. So that means they'll have ions as well as molecules. Okay, have you
Yeah.
ever faced issue of acidity?
No.
Nope. And
Um,
anybody at your place?
mm,
Why I'm
I
asking
don't
this?
think so.
Yeah. Okay, I'm asking this thing because when we face acidity kind of thing, na, so we prefer to take a base. But you know, bases are also corrosive in nature. So we cannot take strong base. We need to take a weak base. For example, your magnesium hydroxide, right? Ammonium hydroxide, these are weak bases. Okay, their strength is not that much. We can consume them. Uh, have you ever like saw that a pink colored medicine is there, which is commonly labeled as Gelusil or Digene, something like this? That is basically your magnesium hydroxide. It's a weak base, right? Now,
Mhm.
why we are using this? I told you that in the classic properties that when a base comes in contact with acid, right, its properties are cancelled. Got it, na? Now, in our stomach, na, we have acid. You know that?
Yeah.
Yep, it is HCl, right? Now, sometimes what happens, the HCl, it starts, corroding our lining. So that leads to quite painful condition, right? So in order to, put a halt on that HCl, what we are going to do, we are going to bring that HCl in contact with base. See, we humans, we take each like possible advantage of the things which we are studying. Got it? So this was the concept which came in our mind that acids, they get neutralized with the bases. So now see, we have solved a it's a very common problem, acidity. People, they do face a lot of these things. So the solution lies in having base. Clear? Okay. So now we are going to further move on in the Arrhenius concept. Now see, what happens is when I am talking about the assets, na, can I wrap this thing if like it's clear with you, right?
Yeah.
So I'm going to wrap the classic concept so that I can have the space to write more. Okay. Okay. See, now what happens when an acid is, broken down, na, it forms H positive, right? It is forming H positive. Will you give me just 1 second? Yeah, I'm back. Okay. See, this H positive. Okay, atomic number of hydrogen, you know that?
One.
Now it has lost the only electron which it had, right? Because it is positively charged. So now it is a proton. Basically, it is a proton, right? So this proton, because it doesn't have any electron with it, so it is very, very small in size now. Okay, it is very small in size. But what happens is now the proton is fully charged. There is no valence shell to, obstruct its power. Got it? There is no valence shell. Na? The electron is gone. So who is going to shield its effect? Nobody. So now it is having a very strong electric field with it. Okay, it is having a very strong electric field. So, like, why we are studying this? Like, what the hell we have to do with the strong electric field being generated by this hydrogen? Now, what happens? I told you that this hydrogen in the form of ion is highly unstable and it readily reacts with water. Why? Why it reacts? This is the reason. Now, see, hydrogen is having a strong electric field with it. That means it is going to attract the negatively charged particle towards itself because it is positively charged. And you know, opposite charges, they are always going to attract each other. Now, in case of water, when we draw the structure of water, it is like this. This is oxygen. This is going to form bonds with the hydrogen. Along with that, it has got a lone pair of electrons. Are you aware of this term, lone pair?
Yeah.
Yeah, what's that?
Where the like the electron is like by itself.
Yeah, they have got an extra pair of electrons, which is unshared, right? Unshared pair of electrons, they are called as lone pair. Sean, actually, what I believe is when you're teaching, it is a dual communication, right? If I'm teaching you, so I have a habit of asking the questions a lot, right? And I do expect the same from you, right? I really appreciate students who do ask questions, okay? And I never mind answering the questions. Okay, got it? So it becomes interesting to interact in a subject like this. Okay, got it? So don't feel bad ki
Yeah.
why ma'am is asking so many questions to me. Okay, this is a kind of interaction, right? We are studying, we are actually communicating. So communication becomes fun when you are talking in the both ways. Okay, it's
Yeah.
very boring to listen to someone, right? And that too for a long time. Okay, so this lone pair, electrons, they are negatively charged, and I have this proton. So what is going to happen? This lone pair of electron is being attracted towards this proton. Got it? And this leads to formation of hydronium ion. Got it? How this hydronium ion comes into being. Now the point is clear, right? Now, whenever an acid and a base, right, they are mixed together, right? What they are going to do, they're going to react, obviously, they are going to form a salt along with a molecule of water. Got it? Okay, can you give an example of an acid? We'll take HCl. That will be
Yeah.
fine. Yeah. Okay, and any base? We can take NaOH.
Yeah.
Okay. Now see what is happening. An acid and a base, when they are dissolved together. Now see what is going to happen. This cation is going to attract this anion, okay, leading to the formation of salt. Clear?
Yeah.
Yep. And this hydrogen is going to come in contact with this hydroxyl ion, leading to the formation of water molecule. Is this
Yeah.
clear? Yep. Now, the whole thing which is happening, this is known as neutralization reaction. Okay, is this clear? Neutralization reaction is
Yeah.
clear? Okay. So what happens? Neutralization reaction is, our soapy to touch, it remained here. Otherwise, it will be difficult to see. Okay, what's the use of this, right? Okay, so neutralization reaction, it's a process in which hydrogen ions being given by acid, right? They come in contact with the hydroxyl ion given by the base to form a water molecule. It is basically the reaction of hydrogen ion plus hydroxide ion, okay, leading to the formation of water, right? Salt is being formed, that is an added advantage, right? Got it? So I hope the Arrhenius concept is clear to you.
Mhm.
Yeah? Okay. See, in science now, whenever things come up, what happens is, obviously, everything has got two sides, right? One is good, one is bad. So when we talk about the advantages of Arrhenius concept, what was that? What was the good things related to this? First of all, it gave us a very good explanation about the neutralization reaction, right? Earlier in the classic concept, we had this thing only, ki acids, when they come in contact with bases, they lose their properties. That's it. This was the thing which was there in our minds. But Arrhenius gave this concept, no, actually what is happening, hydrogen ion is combining with the hydroxyl ion to form water molecule along with salt. So this was the concept, this was the explanation which was given by Arrhenius. Number two, he told us about the strength of acids and bases. He gave us the classification of strong acids, weak acids, strong base, weak base. Got it, na? Earlier, though, we didn't had any idea about this. We were just like, yes, any acid who is sour in taste, any base which is bitter in taste. That's it. We were not aware of how strong is the acid or how strong the base is. Clear?
Mm.
So he related this strength to dissociation, right? To the extent of dissociation. If the extent of dissociation was complete, so the acid or the base was strong. But if the dissociation's extent is low, right? It's not complete, then the acid or the base is said to be weak. Clear?
Yeah.
Next, he gave us the explanation of salt hydrolysis also, which means there is, breakdown of the water molecule. So here also the Arrhenius concept, he was very much, evenly applied. Now the concept is there of if there are good sides, so naturally there has to be bad sides. Now, what were the limitations of this Arrhenius concept? See, if you want to progress now in any field, so naturally you have to work on limitations, right? So we have to see what were the limitations which were posed by this Arrhenius concept. Although he was very successful in giving us so many things, he clarified the concept, but of course, he was there with some limitation. The first limitation was that the hydrogen ion and the hydroxyl ion, what was their nature? Like they were not independently existing, right? As hydrated ions. We were not aware of their existence, so he could not prove that. Okay. Then he could not explain some substances acidic or basic character, like for example, ammonia, right? In case I write ammonia, na, it is a very good base. Okay, now at this moment, I know it is a base, but it does not have OH ion. But Arrhenius told me na, that a substance has to have OH ion with it. Hydroxyl to hona chahiye, it has to be, but it doesn't have. But still, it is basic in nature. Then if I talk about CO2, CO2 is acidic in nature. How come it does not have hydrogen? So Arrhenius could not explain this thing, right? According to Arrhenius, he gave us this definition. But to in his definition, they are not collaborating. They are saying, no, we don't match our vibes with you. Not at all. But still, they are basic and acidic. He could not explain. Then he could not explain the neutralization reaction in absence of water. Sometimes what happens, like this ammonia, it is a base, right? Now, ammonia, when it is going to react with HCl, na, it is going to form a salt. Now, this is a neutralization reaction, but there is no involvement of water molecule, right? What Arrhenius gave us, Arrhenius gave me this thing. He said, whenever an acid and base are going to react, na, a salt will be formed and water will be released. But what is happening over here? He could not explain. Got it? Clear?
Yeah.
So I hope it's clear with you that the Arrhenius concept, what was the Arrhenius concept? How did he come up with the framing of the acids and the bases, advantages of his concept, and the limitations? Got it? So now we are
Yeah.
going to move on to the next. And Sean, the meeting, if it is going to end up, I'm going to restart the meeting. I'll send you the link on the same number which I have. Okay? So you need to rejoin. Got it now?
Could you
Okay.
send it to like a different number?
Sorry.
Can you send it to a different number?
Okay. Can you WhatsApp me the number if no issue is there from that number? Or
Because I'll give
yeah.
you my phone number.
Should I tell my number?
Okay.
Just a second. I'll message. Okay. I'll message you. Um,
I,
I'm
it's through my dad's phone. You'll probably
okay.
miss.
Yeah. I'm just giving my number. Yeah.
Oh, okay. Okay.
Got it now? So you just WhatsApp me. I'll send you the link on that. That will be, I think, much better.
Yeah.
Yep. So now we are going to move on to the next concept. Next concept is also very interesting. I hope Arnia's concept is interesting, right? I find the Arnia's concept to be the most, chilling concept. But
Mhm.
naturally, it could not provide so many things, so many explanations to us. So we are going to move on to the next concept which came on the scene, and it is Bronsted-Lowry concept. Okay. Now the next concept of acid bases we are going to talk about is Bronsted-Lowry concept. Okay. Now, okay. Okay. Now, according to them, now acids, what are acids? Now, at this moment, what we have in our mind? We have in our mind that the substances which are having hydrogen in them, okay, and they are going to form hydronium ion when they are dissolved in water, right?
Yeah.
Yeah. So now Bronsted and Lowry, they came up with another concept that any substance, right? Acids are the substances, right, which have a tendency. Okay, now just understand the statement, what they are given, which have a tendency to give proton. Okay, they are going to give proton. Or I can say acids are basically proton donor, right? Right?
Yeah.
Basically, the concept is the same, but we have changed the gifting thing. We have just, changed the wrapping paper. Earlier, what Arnius told us that any substance having hydrogen in it is going to give us hydronium ion. Okay. Now, they are also saying the same thing, but what they are saying that acids are basically proton donor. That means they are donating the proton. They're giving away the proton. They're giving away the hydrogen, right? And according to them, what are bases? Now, in the Arrhenius concept, he told us that the substances having hydroxide group and giving hydroxyl ion when dissolved in water. But they're saying that bases are the substances which are going to accept the proton. Okay, they're going to take the proton with them. So they are basically substances which have tendency to accept the hydrogen ions. Okay, they are actually the takers, right? So we call them as proton acceptors. Is the concept clear?
Yeah.
Okay. Now, naturally, if a substance is giving something, only then the other substance is going to receive something. Is this
Yeah.
clear? Right now, if I am going to give you something, only then you are going to take now. Otherwise, so you cannot take, right? If I'm
Yeah.
going to teach you, then you are going to learn. That is the simple thing. So obviously, acid and base, they are going to form pairs. Got it? So acid and base, they are forming a pair, right? And these pairs are known as conjugate acid base pairs. Okay, right? So, and the other thing is, when acids, they have given the proton to the bases. That means in the chemical composition, they differ only by a proton, right? They are going to be differing by a proton, or I can say H positive, right? I can say that, I can write down the thing as conjugate acid is in equilibrium with conjugate base along with a proton. Like for example, I say HCl, okay, got it, plus water. So they are going to do Got it? Now, in this case, this HCl is donating the proton, right? If you see, it has given away the proton. So this is conjugate acid. Got it, na? And this is going to, ये तो change हो गया into chloride because it has donated the proton. This has gained the proton to form hydronium. So this is conjugate base and this is conjugate acid. Should I repeat?
Isn't HCl, so HCl, won't that be the acid?
Yeah, it is acid, conjugate acid.
Yeah.
Yeah.
Isn't it just the acid though? And
Conjugate,
H2 is just the base, and then
yeah,
H3O
yeah,
plus
yeah.
is like,
But actually, what the concept is, we are saying that acid and base now, they are actually proton donors and